It is 5 o'clock and time for me to go live, even though it showed that my stream was scheduled for 5:05 for some reason. How's my mic? How's everything sound? Am I overmodulated, undermodulated? Let me have a quick look. No, I think it looks good. I think it sounds good. Maybe go up a little higher. Look at the early birds. Big and Bad Joe, Jose Ferreira, and Big and Bad Joe again, and Da Vinci 10, and Steve Alpha is here. Sounds good, Steve Alpha says. Cliff D is here. Hello, hello. Hi, guys. So, yeah, I don't know why it said 5:05 for a start tonight, but it is what it is, right? So today I officially celebrate my 4th anniversary as DeWitt 3D Canada streaming live. It was actually the 13th of November, but it kind of fell in between my 2 Sunday live streams. So I thought, what the heck? So I'm calling today, this live stream, my 4th anniversary. So November 13th, 2020. Oh yeah, that who could forget? I started live streaming during pandemic. My Create light is not lit. I know, I think the batteries are, I left it on after last stream, and I think the batteries have dead. Let me refresh the batteries on it, since you did point it out. And so because you pointed it out, it means that some people want to see it lit. And you watch, with 3 fresh batteries, 1, 2, 3, it'll look all purty. Why won't you close? Oh, there we go. Look at that nice battery case, by the way. Costco. Not that anybody wanted to know that, but hey, what the heck. So let's put 3 fresh batteries in this guy. Thank you very much for the congrats. 4 years, man. I've come a long way. I remember my first stream, I was extremely shy. Let's see. Ah, oh, look how bright that is now. Now let's put that back down there. There we go. Now it's lit up. Now she's lit up. Perfect. I've also got this sign here lit up now. Polymaker being the major sponsor for my channel and for this build. And a thumbs up for DeWitt 3D. Yeah, let's get going. Poof. So 17 people already, and we just started streaming. So, okay, so where we left off last week with Wally here, he's got an open belly here. Look, I can tickle. Oh, that just seems really bad that I'm sticking my hand in his open belly. But we're going to work on the electronics. I did a little bit of wire lengthening, etc., off stream. I need to make a plate for inside his belly so that the boards don't touch the screws here. So if you'll bear with me for a few minutes, I'm going to swing us over into Fusion 360. I used the high-tech method of nice Wally model. Thank you, Philippe Lal. I'm not going to even try to pronounce your last name, Philippe, but Philippe, twin elbow blow. Thank you very much. I use the really high technological method of designing a little plate for in there by sticking a piece of paper that I'm going to make it 120 by 110 millimeter, and then pushing the paper down until I punctured the holes in it, and then measuring the holes for the distances and stuff. And I'm going to model something up. It'll take me no more than 5-10 minutes to model up a little thing in Fusion 360. I wanted to do this earlier in the week, but I was really busy at my full-time gig. And then, so I'm going to model this up real quick, and we'll stick it on the printer and get it printing while we do the wiring up. If you guys are okay with me doing a little bit of Fusion 360 work on this stream. So, and even if you're not okay with it, I'm in control, so it's going to get done. So hope everybody's had a great week. So Shadell 3D, hello. GMND is here as well. Yeah, and I don't think I've missed anybody yet saying hello for all the folks who have spoke up. If you're new here, and you are new here, you want to follow this sign and do the thumbs up for sure to like the stream, and subscribe if you're not a subscriber. We will be doing at around, it's 5:04 now, about 6:30, which is an hour and a half from now, we'll be doing a draw for a free roll of Polymaker filament. Not one of these, but this is just to show you what Polymaker filament looks like. We'll be doing a draw for a free roll of Polymaker filament for everybody that's on stream and anybody who enters and anybody who's here if their name happens to be drawn. So, okay, let's get right into it. I'm going to sit down because I can. because I can. I'm going to take a sip of water. And I'm going to do a really quick thing in Fusion 360 here. This is not meant to teach anybody how to use Fusion 360. This is not meant for me to say, oh, how do I use it? Because what I'm doing here is really, really fast, really, really quick. I've already got the base for it. I'm just going to really quickly do the design for it. We're going to get it printing, and then we're going to go ahead and start working on wiring up the electronics. So you're finally getting your Wall E T. Nice. TPU. Oh, okay, TPU to do your Wally track. Cool. Very cool. Okay, so oh, look at the fancy new keyboard. Look at that. It lights up. Ooh, pretty. Okay, anyways, we talked about the new computer last week, so cool. Okay, so let's switch over to the display. Let's bring up Fusion 360 on here, and I've got the base of the thing made already. So I'm just going to quickly do the things I need to do on this to get this little base plate made that I want to get made for inside, so that the electronics don't touch all those screws. So I'm doing 120 by 110 millimeters on it. I'm going to create I'm going to do a mirror on when I do this. So I'm just going to create 1, 2, 3, 5 circles is what I got to create. So we're just going to go, it doesn't matter, one, and we're going to have one down around here somewhere. And we're going to have, it looks like 3 of them. So one here, and another one here. Okay, so now we're going to just dimension these circles. So what I need to do is dimension and this, oh, not dimension, sorry. I got to get my circle sizes right here. Boom, okay. So this is, I need this one to be, these little ones are 5 millimeters. Oops. Okay, and the little one here, just going to quickly 5 millimeters. This one's 5 millimeters. And this isn't going to be the prettiest sketch, so don't worry about, the fact where all these numbers are going all over the place. And if I'm not mistaken, my big one, this last one, which is where the motor wires are coming through, I want that to be 8 millimeters because the wires are fairly thick coming through here. So we're going to make that 8 millimeters. I'll just do it 9 millimeters. Okay. And then this guy here is coming in 9 millimeters from the outer wall, and he is coming down 18 millimeters. I know it's not over constrained. Stop. I wanted to come down. Oh, see, he's locked himself to that. That's okay. I will worry about that in a minute. Okay. Oops, sorry, excuse me. I'm rushing here because I don't want to spend all stream on this. So that, cancel. Let me just undo a couple things here. Okay, here we go. I'm going to undo that constraint too. Actually, I want to undo that. I don't want that. I don't want him constrained to the line. So I'm going to actually delete him. Helps if I hit the right button. There we go. I didn't mean to constrain these guys to the line, which is something I didn't want to do, but that's okay. And I'm just going to get rid of this one. It's just me, and there's probably an easier way to do this, but me and my limited Fusion 360 knowledge. So we're going to make him there. We're going to make this guy there. That's fine. We're okay there. Okay, now we'll get these done. We'll do this proper this time. So this one was going to be 5 millimeter. And this one was 5 millimeter. And I am by no means Fusion expert, just so you know. So, okay, so from there to there was 9 millimeters. 9. And from here to the top is going to be 18 millimeters. Okay, perfect. And this is going to be 9 millimeters from here to here. If I could actually touch something, there we go, 9. Hey, Tim, sorry I missed last week. You finished Wally yet? Wally's coming pretty close, Brent. We're just starting some electronics right now. So, and I'm just really quickly just making a electronic thing. And we went from the middle of that one to the middle of this one to B. Why are you telling me that you're going to be over constrained? You're not constrained anywhere. I want to drive that one to be 80 millimeters. See, that's not right. I didn't get that measurement. Bear with me 1 second, folks. In between those, we're going to be 60 millimeters in between. So how come? Okay, let me undo this. I never understood that. That's fully constrained, but it shouldn't be. It's only 9 millimeters from there, but I want it to be a specific distance between the two. Oh, I know what happened here. I got to remove that constraint, that 18 millimeter constraint. Okay, so I want the distance between these two, here and here, to be 60 millimeters. Oops, I don't want J60, I want 60. I'm still getting used to typing on this new keyboard. And why are you coming over? See, this sometimes I get confused in this, and I'm trying to rush as well. Why is that constrained to that line? That's annoying the crap out of me. Sorry guys. This is not supposed to happen like this. Okay, we're just gonna start fresh here. Thanks as always for a fun end of the weekend stream. GMND, thank you so much for the super chat. I appreciate that so much. Thank you very much. And just because of that, you get one of these. Super chat. Thank you so much. The affiliate link is broken. It's not including off 23. Oh, really? Okay, Dan, I'll have to look into that. Thank you. I didn't realize. I know I fixed the Wally link, but my affiliate link, okay. I just copied it from my last stream, and I assumed that would work. So something is happening with my affiliate link. So, but thank you for pointing that out. Okay. I'm just gonna really quickly do something here. Bear with me 1 second here. These are locking places I don't want them locked to. So I'm rushing this, and I usually know what I'm doing for the most part on this, but obviously I'm doing something wrong here. Okay, why are you not even letting me? There we go. 5. I think if I just go ahead and five. It's not usually this difficult, believe me. Nine. And this one's 5. Okay. So I'm just going to bring these things in. I'm going to bring these in here. Bring this in here. Bring these. I just didn't want them locking to anything when I created them. Okay, so now I should be able to dimension this guy. He's 9 millimeters from the wall. This guy should be 9 millimeters from the wall. And between them should be 60 millimeters. There we go, that's better. And then from there to the top, oops, from there to there, no. From there to there. Okay, I'm not able to click there to there, no, to there. There we go. That should be 18 millimeters. There we go. That's what I wanted to do. Finally. Okay. At least it's not blue. Okay, really quick. 45 millimeters from the top to the middle one here. This guy here should be from here to here. Just reading my notes here real quick. 45 millimeters. Okay, and from the top to the other little guy. Why didn't I get that? See, sometimes you got to make sure you get all the correct dimensions sometimes, all the correct measurements. That's going to be 33. From here to here is 33. Okay, and in between those two middle ones, see, I didn't get that. Oh yeah, 18 millimeters in between them. So from here to here, 18 millimeters. Okay, and then this guy, let's see, that doesn't look right. Something's not right here. 18 there, 45 to the top, and 33 to that one. Or did I mess that up? Oh yeah, I did mess that up. Sorry, it's 38 to that one. This should be 38 millimeters. Helps if I can read my own writing. Okay, that looks about right. Okay, that's about right there. Everything's where it should be. Here to here. That should be 38 millimeters. And from here to here is going to be 38 as well. I don't know why that didn't. There we go. And the only one I'm missing is from here to here, which should be that should be 33. 33. Yep. 33. A lot of numbers on the screen there, but what the heck. Okay. Now I'm just going to quickly, once we get this printed, we'll start the electronics. Give myself a guideline here. Okay, and then I'm going to quickly do a mirror. And we're going to mirror you. I said you. All of you guys, and then we're going to mirror you on this line. And we're going to go okay. And we're good. Our sketch is done finally. Oh my goodness, that was painful, wasn't it? How thick will the wall be? Mark Flanagan, hello. Troubles because everyone is watching. That's usually the way it is. That's usually the way it is when everybody's watching. I get a little bit nervous, you know, like that. Oh, one thing I forgot to do on the sketch. My apologies. I'm just going to go back, edit the sketch. One thing I forgot to do is I want to take this. Or actually not that. I want to go ahead and I want to create an offset from this. And I'm going to come in. I'm going to make it maybe, how thick do I want that to be? I'm going to say 2 millimeters should be plenty thick for that wall. Or even 2.5. Yeah, that'll be fine. 2.5 millimeters would be fine for that wall. So that's really all I need to do for this. So we're going to finish this. I am going to go ahead and extrude. We're going to extrude the wall and the plate. We can leave the holes for now, but we're going to come up and we're going to make it, how thick do we want to make it? We're going to make it, say, 2.5 millimeters thick as well. Should be fine. Okay, and then we're going to go ahead and show that sketch again, and we're going to come back here. And I think I determined that I needed to make this, oops, not that one. We want this outer wall, and I think I said that is going to be, who's texting me? Hello, everyone. Joe had a, oh. Okay, I got to read that after. That's not good news. 9 millimeters deep is what we want to do. So we want to go minus 9. There we go. So I can go ahead and hide that sketch. So this is basically what I want to do. It's going to be a plate just like this. I didn't need to make these holes particularly, but I wanted to make those holes so that I know where the screws underneath are lying. These holes here are where the wires are going to come through from the motors. So that's basically the plate that I want to make that's going to slide in there for him. So, and again, those are, actually, I didn't even really need to extrude these holes, but what the heck, why not, right? Because really the whole plate would have covered. I only needed these ones. Why did I have to make all those other holes? I really didn't need to do that. I just wasted a whole bunch of time. I really did. Lesson learned. See, and it's also just because everybody's watching. Okay, anyways, I'm just going to go ahead and take this, and I'm going to actually add this to that. And, oh, not that one, sorry. This one, this one, this one, this one, this one. Over here, I just made more work than I needed to. And I just realized that now. And then we're going to go, okay. There we go. Oops. And my body. There we go. All I really needed was this. Okay, that other stuff was all a waste of time. Lesson learned. That's okay. Fair enough. Gave me some practice. Just going to call this Wally plate. Okay, fair enough. I'm going to save it. And I'm going to export a STL. And we're going to export it to my desktop. We'll go to downloads. Why not? Okay, there we go. Sorry. Anyways, that was a big waste of time on some stuff, but hey, that's all right. So I'm just going to quickly open my slicer here. I know I downloaded Bamboo Slicer. I better have downloaded my Bamboo Slicer. There we go, Bamboo Studio. I hear singing upstairs. I think Ethan is singing. Maybe he's going to come on and sing for us tonight. I'm going to skip this version for now. So there's our Bamboo Slicer. Let's just make this a little bigger. I don't know who he's singing to, but Ethan is upstairs singing his heart out. Okay. Show night in chat. Slow night in chat. I've been here 5 minutes and no talk about food and not one fart joke or innuendo. Too funny. Dan likes watching casual work in Fusion 360 instead of pre-recorded tutorial. Yeah. You know what? When I'm using Fusion 360, I'm usually a little better at it, but I'm kind of rushing a bit tonight, which is, I've done some pretty cool stuff in Fusion 360. One of the coolest things I've done, I'll show you guys real quick. I know you don't care and blah, blah, blah. This is just but one of the coolest things I've done was, I did this guy. I did a drawing up for a paper shelf that I'm going to be building for my office. So that was my drawing, so I could get my wood and all of my pieces measured up, because that's one thing I've done. And then one of the coolest things and more difficult things I've done, if I can find it, was this window trimming tool that I designed up and modeled from an existing one that I had, this guy right here. So this required a lot of different bodies and so forth. So this was really a cool design that I did up, and I actually printed it and did a good print of it, and it actually works really, really well. So anyways, I digress. Let's get out of here because we're not here to talk about that. We're going to get into this. We're going to grab our device. We're going to print it on the DeWitt 3D A1 Mini, and we're going to go to prepare. And this A1 Mini, where's my A1 Mini? A1 Mini 0.4 nozzle. Here we go. There we go. So let's go ahead and drag in that piece, and then we're going to get started on the electronics. And this PC and my download folder where I stuck that, and we'll drag him over in. There's the bay. There we go. Okay. I know I don't have green filament on that. Helps if I sync my filament. There we go. White's fine. We're going to do automatic, so it's going to be in the bottom. We will make this guy, I don't even have advanced on. We're going to make this guy 3 wall loops, 5 top, 4 bottom, 15% infill's fine, blah, blah, blah. I'm going to use gyroid infill, slice the plate. Looks like it's going to be a 1 hour and 7 minute print. Fair enough. Print the plate. Do it through the A1 Mini, PLA A1, and we will send. And there we go. Should hear the A1 Mini sing its tunes in 1 second. Okay, got that done. Out of the way. We're going to start printing that piece. Make this window big again. There we go. Anybody have the A1 Mini and disable that tune? It's kind of cute anyways. Okay, so let's turn our Space Mouse off now that we're done in Fusion. Let's move our keyboard aside. I am a little more adept in Fusion, trust me, but when I have an audience watching, sometimes I get a little nervous. So, okay, I got to open up the Wally model over here again. Oh, I had to reboot my computer, so I closed all those windows, didn't I? So let me go ahead and open the model up and show the electronics diagram again. So that's going to be on Printables. And there is a link to the Wally model we're building in the description. I'm okay with that. Printables, and let's go Wally. Let's find them. There's Wally right there. Let's pull him to the other screen. And let's give you guys a view of this. Doop. And there's Wally, and we're going down, and we are basically following the electronics wiring diagram right here, is what we're doing right now. Okay. No A1s, carbon and P1S. Cool. I got the A1 Mini, and I got an A1 on its way to the studio, and I have a couple A1 Minis at the office, and I got a P1S, some Vorons. My K1 is gone. My Prusa Mini is gone. And I'm selling a couple more printers off as we go. So cool. Okay, so the wiring diagram. So what we have is we have an Arduino board meshed with an Elegoo Uno R3. So an Uno board on top of an Arduino board we have here. So that's this guy right. It's this guy right here. So we've married those two boards together like they should. Now, apparently I'm going to need a Raspberry Pi for this too. Actually, no, these aren't quite sitting down the way they should be, but this board is going to marry with this board. Like so, okay? Wally sitting behind you with arms out like it looks like the robot equivalent of Frankenstein's monster. So true, right? Look at that. Ah, help me, I'm dead. So anyways, okay, so we got these boards put together. We have the buck converter. We're going from 12 to 5 volts, or is it 24 to 5? We'll figure that out. No, it's a 12 volt power supply we're using. So we got the buck converter here. It has a power. It's a little different because we don't have to solder anything on this at all, because we have our wire connections here, and then we have this, which is going to go to the battery as the A1 Mini does its vibration compensation as I'm talking. Okay, and then we also have the 12-channel servo converter, servo controller, which is right here, which I believe is going to control the all the servos, of course. And I've basically taken the wires and put the wires on like I need, because we basically needed 5 different colors of wire. And the one that came with it had 2 whites, so all I did was take off one of the whites to give us our 5 colors. So there we go. So if we go back to the display now, looks like what we have to do to wire these things together. Servos are in Wally, so I'm not going to worry about the servos yet. The servos will plug in to these connectors right along here. Okay, and in the order that we see on the diagram, it looks like it's the first 7 plugs are going to be the servos, and depending on which servo we're controlling is where it's going to plug in here. So the next thing we have to wire up now, though, is I have to see if I have an actual 12-volt battery. What I have for a battery. I think the ones I have are actually quite big and powerful. So as far as getting the boards put together, so we have to go from this guy here. So if we what I'm looking at now, and I'm going to switch screens again. So we're going to get the wiring going from the Uno with the motor shield over to the servo controller board. So we have to run some wires from this board to that board. Okay, and then we have to obviously run this red, which I believe is the power. It's the 5 volts. And then we're going to have to run some wires. We're basically piggybacking. We're running the battery into the buck converter, and we're running the battery into the Arduino Uno motor shield. We're running it into the full 12 volts, it looks like here too. So let's go ahead and get these two boards kind of stuck together, and then we'll worry about the battery, and then we'll pull Wally over. And, we'll just shoot the poop for a while, because when Wally comes over, I want to have this little piece printed for him. So, yeah, that's what we're doing. So, as you can see, I'm a little bit disorganized here, but what the heck. So, let's go ahead. We'll go to this camera right here. Okay, so we're going to come out from here. Oh, I need to get some female ends here, because I just thought of that. Because basically, we're going from here into this guy, but I can't use these ends. So I need to find myself. I got to see if I have any of these. I know I have some male to female somewhere, but I want to see if I have enough to do this. So let me check and have a look here. Hey, Richard McLean from Las Vegas. So sorry guys, this stream is kind of all over the place, but hey, it is what it is. Let me grab my electronics bin here. Let's see what wires I have. See if I have any of those male to female already done, so I don't have to make them. I think I have some, but I'm not 100% sure. Let me just quickly go through this one, and then I have another source for wire. We're going to need some of this wire out anyway, so I'm just going to leave that one out. There's that one. That's all female to female. This one is not what I need. There's the bag I was looking for right here. No, that's not what I need either. I may have to make some of these. That's all female to female. I was sure I had some, but female to female. No, hi from Alabama. Joseph Carver, Alabama. Hello, hello. People from all over the place here. This one is, those are all male to male, or female to female. Darn. Okay, well, I'm going to have to make some wiring. Hopefully I have the proper connections for these. Otherwise, it's going to be a real short stream. I'm going to put that one out here. Actually, no, I don't need this. I've got the ones there. I'm going to see if I have the proper ends for those, so I can actually make the wires. I have another electronics bin somewhere, but I'm pretty sure, let me just have a quick peek over here. I'm pretty sure I don't have any of those in it. Let me just have a quick peek here. And then I have one more source for my electronics pieces, not in there. Ah, darn, I was sure I had some of those wires. What a shame. Not that I mind making wires, but it's not the most exciting thing to watch on a stream as somebody having to make some wires. Oh, well, anyways, let's see if I have the proper connectors to make those wires. Okay, let's look down in my stash. It's not that one. Is it these ones? It's not that one. That might work. No, hang on. Da, da, da. Just talk amongst yourselves while I'm bent over here. Okay, let's see what I got here. Let's see what I got here. Don't think that's going to be what I need. Definitely not those. Definitely not those. Any ideas on next project when Wally is done? I'm thinking of. I got a few things on the go. I do want to do a life-size dummy 13. We talked about that a bunch of streams ago. Yeah. Oh, what is that? Both servo shield and I2C breakout board. Why both? Dan is asking. I don't know, to be honest with you. It's a motor shield and an Uno board. I don't know. I'm getting into territory that is unfamiliar to me, which is because after all this motor and everything get put together, apparently I need to connect this to a Raspberry Pi, and then there's a whole other section that he sends me to for programming the Arduino board and all that. And that is just like, that's all German to me. I'm going to be doing a lot of research and studying and trying to figure out what's going on with this. So, can you drive servos like this with an MCU for a printer like a SKR Mini? I don't know, Joseph. I'm not sure. See, the way I did the other robots was I used actually a remote control with a for the servos. It was a well, let me go show you the type of remote we had, because I do have another one here. It's right up here. It is, which one? I believe it's this one. I believe it's this one. So this is a 6-channel now, and this is the way I thought it was going to go, but it's not. And so in these remotes, these things come with a servo controller under here. So if I open this up here, so these things come with a receiver. And in this receiver, here, I'll just show this on the camera here real quick. In the receiver, so these things come with this is a 6-channel receiver. You plug the servos in the end of here, okay? And then of course, this receives a signal from your actual remote control and controls the robot, but you have to have motor, motor controllers and everything in it. So this one we're doing right now is a fair bit different in the way it works. And I thought, you know what, why not try it? It'll be a challenge. And I kind of fear, let me just put this back in here. This is a new remote that I have, control. I kind of fear that I bit off more than I can chew when it comes to getting this thing all programmed and running. But I'm not going to give up. I'm gonna try it because it's something new, and I like learning new things. So we'll see what happens. So that's the way we did the other droids, the other robot builds we've done. This one's a little bit different. This one is programmed through a Raspberry Pi or something like that. So it's like way above my pay grade. Hey, 3D Medic Vince. That's when things get interesting. Yes, it is. It really is. Okay. I don't know if I have, see what I need. So I need to make the female end of, or the male end of this connector here. So we've got these things connecting onto the board. Forgive the paint on my hand. I was doing some painting earlier. And I need to make the male end of these pins in order to go into the Arduino. And that's what I'm trying to find right now. And I thought I had, and I'm trying to find where I put that kit. I had a kit to make those pins, and at least I think I had a kit to make those pins. And I'm not having any luck locating it. It's not that one. Maybe is it? No, those are ball bearings. wasn't this one. These are JST connectors. It was one of the JST kits I had, I'm sure. But none of these are going to allow me to make a male pin. And it is here somewhere. Anyways. This may just be like a giveaway a spool of filament and call it a stream if I can't find these pins to get these boards connected. Anyways, doesn't matter. It is what it is. Typical live streaming stuff, right? I always say that. Live streaming, anything can happen. I am just looking for that one kit that I know I have. Let's see. Not that one, not that one. I've got stuff everywhere. Everywhere. And I do not see what I'm looking for. Maybe I don't have them. Maybe that's a whole other thing. Maybe I need to order. I know you can buy these as a male to female wire, but I definitely need them to be male to go into the Arduino. Yeah. Here I have 33 people watching me struggle to make the next step. It's like, I can't handle this. Yeah, I can. I'm not worried. Oh, what's this? Is this it? No, that's my heat shrink tubing. Oh, man. Here, let me distract you by bringing Wally over, and you can see how Wally's doing while I'm looking for these pins. Wally's like, oh my God, doesn't know what he's doing. Shakes his head. Raspberry Pi and Linux is as easy to learn. I use Raspberry Pi to run the hologram boxes you made. Oh, okay, Russ. I mean, yeah, I'm sure it's not hard to learn, but it's one of those things that stresses me out when I'm thinking, okay, I got to learn something new again. But I am really, I just spilled some water on me. I'm half decent at following instructions, and there are good instructions on that. But if I can't find the piece to make these wires, I'm kind of hooped. Now I could pop these out. I wonder if I just pop these out of here, if I can just plug them straight in from there. No, because that's going to be a female receptor, and I need a male injector. This doesn't sound good, does it? Possibly, hang on. I wonder if these on their own, no, probably not. Let's just see. On their own would plug into there. Oh, they would too. But there's no shielding on it, which is see, that'll work. These ones. I can put the wires on there, and then I could just put some heat shrink over it, and I could make them work that way. That's one possibility. Okay, let's not dismiss this. Ideally, I'd like to have a pre-made wire, but it is what it is when it comes to that. So, and maybe here's these ones. These have a little more substance to them. And yeah, that would work too. That would work too. All I would have to do in this case is crimp my wire onto these, heat shrink them a bit so that there's no crossover, and then those will sit in there no problem. They're not the proper pin, but it'll work in a pinch. Okay. I know I had the proper one. Definitely had it somewhere, but it's not going to be found right now, and I'm not going to waste any more time on stream looking for it. So we're going to make a few wires. Let's just do this. Let's just do what we got to do here. Let me grab a couple tools. We'll make it work. We've got some heat shrink tubing. Hey, Wally. Oh, hey, Wally. Say goodbye for a minute. Hey, Jose. How are you, sir? And Sergio's here, I see. Hello, hello, hello. If you're not sticking around for the entertainment that I'm giving you here, at least stick around for the Polymaker filament giveaway, which is going to happen in about 45 to 50 minutes. And now I just got to make a few wires here. Not a big deal. It can be done. We're just going to make a few wire ends. Here, I'll even give you a close-up so you don't have to look at me in the face and watch me suffer. So we're just going to cut all these off. Yeah, I know. Easier to buy them, but cheaper to make them. Especially when I have all the tools. Okay, and before I forget, we're just going to grab some heat shrink tubing, which I think the red stuff is going to be just fine. Will Wally be Wi-Fi connected with a Raspberry Pi? You could make a web app so stream viewers could control it. Oh, again, Joseph, that's above my pay grade. Sounds like it would be a great idea. But yeah, if I can connect it to Wi-Fi to Raspberry Pi and viewers could control Wally, do I want my viewers controlling my Wally? The ranch kid, hello. Okay, we're just gonna get some of these wires going. I was hoping to get all the wiring and everything done in the stream tonight, and then, you know, next thing I have to do is program Wally, but I may have to steal I'm probably going to have to steal a Pi out of my other Voron 0.1 because I don't have another Raspberry Pi. Last Pi I had, I used in the Barbie build. So, oh, here, let me go ahead on here and add. I haven't got my camera set up exactly the way I want them since I upgraded this computer. So let's go ahead and add that there, and then let's turn me around because I feel like I'm standing on my head right here. So let's do that, and then let's go ahead and shrink that up there, and we'll put that right up in this corner here, and that looks a little bit better for viewers so you can actually see that I'm a real person. Hey, pop away. Okay, so let's go ahead and strip a few wires here. And we don't need to strip a lot, just enough to see a little bit of the wire. Okay. Look, it's a live stream on how to strip wires. Yay. There we go. Okay. Let's grab some pins. And get this in the crimper. It's a play-by-play. Right about, is this one here? Come on. Don't go messing with me. There we go. Hopefully this is going to work. If it doesn't, I'll have to buy the actual connectors, but I think I can make this work. Oh no, that's not going to work, is it? Oh yeah, that's going to work. What the heck? Then I bring the heat shrink up to here, and then this guy's going to plug in. Oh yeah, that should work fine. Okay, so we'll just put the rest of these pins on. There we go. This should work fine. Thanks for adding realism by looking for, yeah, well, exactly. You know what? That's what I like about live streaming. I can't hide anything. If I was making a video about doing this, you know, I'd be editing out the frantic search for something I know should be there. I'd be editing out me struggling with these little pins with my massive mittens. I like the honesty of live streams. Oh, and I like the honesty when you wreck a pin and you go, crap, I wrecked a pin. So Glad you didn't miss the wiring fun. Yeah. Maybe maybe this needs to go in the larger one here. I don't know. Let's see if this will work in that larger spot there. I couldn't crimp these pins for the life of me when I first started this whole streaming thing, but I've learned a bit, and I just wrecked another one. There we go. Just wrecked another one. These are really interesting size connectors that I'm making here. I don't know if I'm actually even using the correct crimper for them, but we're making it work. Takes a little longer making it work. Takes a little time. Bow wow. Is that Mike and the Mechanics? I think it is. That worked. And another one here. Okay. This is the how not to do it training series that I'm showing you here, because you shouldn't really have to make these pins like this if you have the proper pins to connect to the board anyways, but in a pinch this will work. See what I did there in a pinch is I'm pinching these wires crimped closed. I hope these are going to work. Crimp is easy if you practice enough. Oh, it is, and I've had a ton of practice crimping. There we go. And one more wire go. Here it is. Oh, I don't want to put a frayed wire in there. I don't want them to be scared. See, I did there again, a frayed wire, scared. I know, pathetic, sad. There we go. Okay, so we got all the crimping done. I'm going to grab my heat gun. Somewhere here I have my heat shrink gun. Where did I put it? I used it last week. Oh, that burns me when I can't. Oh, where did I put it? Did I put it away? You know, you'd think a guy would get ready for a stream by saying, okay, I'm going to stream tonight. I'm going to need this, 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 and this on my live stream. Have it handy. Yeah, right. My heat shrink gun. I used it 2 weeks ago. Did I leave it on the tabletop here? There it is, right there. I did leave it on the top here. Aha! I found it. Turn it on, warm it up, and we'll get these things shrunk down. Again, this is not the way to do this. This is called desperate times require desperate measures. And I can always order these proper connectors and then just easily replace these. At least this gets me going. And this is why I only have 2,200 subscribers. Nobody wants to watch this crap. I'm just kidding. Come on. The problem is you put things away. That's true. That is a problem. Always handy on the top of your bench. But my bench gets so full. And then I think, okay, I need to put things away so I know where they are. Or I'll make that really dumb mistake of saying, okay, I'm going to find a more efficient way to organize my studio. And so I go ahead and I start moving things around and I switch things up and I think, okay, this will work good. And then I totally lose things. Then I can't find anything. So yeah, it happens. Then you need another bench. Or less printers, because I've got a full bench down here, but too many printers covering the bench. So there we go. We got it all wired up, no problem now. Always put things in the same place, no matter where. Well, exactly. Well, ideally, I was supposed to. I'm actually still working on this. I'm putting a lot of my things over on this threadboard wall I made. Hope in the effort to keep things organized. So, anyways, we're back and we got it now. So we got this down. So we're going to actually follow the color scheme. So we have black. I'm actually just going to separate all these wires so that there we go. Okay. So the black wire is going into number 4. 1, 2, 3, 4, which is the ground. Okay, we have the ground. Then we have the yellow wire, which in this case is the white wire, is going into, what number? That's the third one from the bottom. 1, 2, 3. So that is the slot number 10. Yes, that is right. And our third one on the drawing, which is green, in my case is purple. I guess I could have switched it for the green, but that's okay. It goes into number 1, which is the SCL. Okay. And the fourth one, which on mine is blue, and it's blue on this one too. Look at that. Goes into the second slot, which is the SDA. No idea what those initials stand for, SDA. And then we have the last one, which is green on mine, or red on this. That comes around the other side, and that goes in the plus 5 volt right there. So that comes in there. So there are the wires going from the servo controller into the Arduino, which is obviously going to program the servos based on where I put the wires. I have no idea if that's going to work, but according to all this stuff, it should work. Okay, so that's that. Gridfinity, yeah. Gridfinity is a great system. And if I had room to make some Gridfinity stuff here, I probably would, but it's just a matter of finding the space for everything. So this threadboard wall is probably similar to a Gridfinity type thing. Okay, so now we have to go from the 12 volt battery. Let's see what I have for a battery. See if I have a 12 volt. I know where my batteries are, so there's no worries there. Let's see. I keep my batteries in a fireproof battery bag. This one that's pretty much a 12 volt, 11.1. And I don't think we're going to need a big battery here for this, but let's just see. This is also a 12 volt. That's a big 5200 milliamp 12 volt. And what else do I have here? I have another 550 milliamp 12 volt. They're actually 11.1 volt, but they are 12 volt. And I have I have a few of them. So these are all 12 volt lipos. 12 volt, 450 milliamp, 550 milliamp. I think I'll stick with a 550 milliamp. And then I've got another. Yeah, these ones are too big. These are all 12 volt, but they're all obviously way too big for Wally. And this little guy is another 550 milliamp 12 volt. So, yeah. So what I'm gonna really quickly do here is I will just check and see how my batteries are looking power-wise. So we have if you're dealing with LiPo batteries, you want to get yourself a really good professional balanced charger-discharger. That's what I learned building the other robots. So we're going to plug this charger-discharger in, and I just want to get a reading on these batteries. So let's just see where we're at. So you're going to go in here, and I just want to get a reading on you. Here, let's see. I'll give you the overhead. Actually, this camera may show it. Actually, I can show you on this camera possibly. Yeah, let me get a reading on this though. LiPo. And I want to get charge, fast charge, storage, discharge, balance charge. I want a status. These are 3 S's. 11.1 volt. Okay. Oh, maintenance port. My bad. Oh. This isn't going to tell me. That's okay. I'm not going to worry about this right now. I haven't used this in a while. I forgot to plug in the maintenance port on it. But I'm not trying to charge it or discharge it right now. I was just trying to see how much voltage it had. But it's okay. So we'll use one of these little batteries to power Wally. 1 kilowatt Wally. Let's go. 1 kilowatt Wally. So this is a 550 milliamp, 12 volt. So this should be plenty to power Wally. But I want to just make sure. I just want to see what we have as far as charge on this thing. So give me a second here. Oh, wrong one. Let's grab my meter. Turn it on. We're 11.44 volts. Let's see if I can show you this. There we go. So this battery's got good charge. It's 11.1 volt battery, 11.44. So that's good battery power. Now we're going to need to be careful when we work with this because we're likely going to have to cut the battery connection, but I do not want to short the battery out. The last thing you want to do is short out a LiPo battery. Not that I've had experience with shorting out LiPo batteries, but hey, you need a 7-second quarter mile out of Wally. Well, I'll tell you what, if I put a couple of those big batteries in series on them, maybe. Okay, so the battery is going to connect. We have to connect the battery to 2 places. It's got to go to the buck converter, and then it's going to run down to the Arduino board to here, to the power input here on the battery. Voltage in and the battery on this. Okay, so for the buck converter, the battery in this particular one, we have power from the battery coming into here. So we got to wire the battery up in here. And then the output. So we have our input voltage here. Output voltage is going to be down here. Okay. voltage in minus, and this is 5 volt out and ground. Okay, so I have some connectors here. Where are those? There they are. I'm going to, in this case, it'll take up a little bit more room, but I'm going to use some of these Wago connectors to do this, because we want to wire. I'm just going to be careful about this when I cut these wires on the battery too. Actually, if I don't have to cut these, I don't know if I have a plug that I can wire. I just hate cutting batteries on a LiPo battery. I hate cutting the connectors on a LiPo battery. But I'd rather see if I have a plug that I can actually plug into this one, and then we can split the wiring, split the battery, because we need this for doing the balanced charging. That's right, I don't want to cut this if I don't have to. Yeah, okay. But either way, so this is going to the battery. We need to plug this into the battery, but we're going to split off of this. And we got to go to the Arduino with this. So I need a red and black wire. So I'll just cut a little piece of wire off of here. Why are you not? There we are. And there we are. And I just have to see if I can find a connector that I can plug in on that battery. Where's my tools? There's my Wago tools. And I'm going to need probably... Let's see if I can find something for that battery connector. Give me 1 second. Let me grab my electronics box. That's a pretty standard type plug there. Let me put this on the big screen. I believe I had one. Where's the battery? There it is. I just need the male end of this, which I thought I saw. No, that's not you. Too big. Nope. Right there. I knew I had one. Right there. So this guy. There we go. Perfect. So that's, I've got this. So we've got a, that way I don't have to cut the actual original battery terminal. So I've got a male end to go in there, and I just pulled those out. Don't want to do that. That wasn't in there the best. That shouldn't have come out that easy. Should not have come out that easy. The pin is bent in on this one. Okay. Anyways, it's okay. It's okay. This stream is not going nearly as well as last week's did. Can you tell I'm a little bit nervous when it comes to electronic stuff? No, you can't tell that? Come on. So where did that... How did that get squished in there so far? That's better on that one. So this should... There, that won't come out now. That's weird that those pins got bent. This one... That's much better. Much better. Now these should plug into this no problem. Like that, and then, yeah, perfect. Okay. That was just really, really, really weird. Okay, so now I can go ahead. Obviously, I used this for one of these little batteries for something else before, so now I can just cut this end off. Whoops. It's because you're here this week, Brent. Is that it? Watch for polarity. Yes, definitely on a LiPo battery, we want to make sure we get the polarity right. Yeah, I've actually shorted a LiPo battery before. It's not pretty. Not pretty at all. I mean, it's dangerous, yes, in a sense. Not as dangerous as overcharging them, but anytime you short a battery and you get the little sparkies. But no sparkies on this stream anymore. Oh, man. Oh, I get carpal tunnel in my left hand, and it kind of bothers me sometimes. Okay, so we're going to, from the battery to here. From here, we are going to splice into the buck converter. So let's go ahead. Actually, no, it's going to be better. So if we go from here, we have our positive, our negative, and then that can go out to the buck converter. Let's actually use we need the three-way ones. We need the three-way ferrules. This one and this one. I think I need the three-way, or the three-way Wagos. And then I just gave away what I'm going to do. I'm going to put ferrules on these things. Where's my ferrule kit? There it is. Just to make this as safe as possible. Anybody bored yet? I know you're all sticking around to win some filament, which is great, because I love giving it away. Last month, a killer Raspberry Pi 2. You killed a Raspberry Pi 2.0 last month? Ah. Hey, Andrew Humphrey, there you are. Nobody's bored yet. Good. You're just waiting to see me electrocute myself or do something silly. I know it. Right? Right. Okay, ferrules. I love the word ferrule. Okay, let's get some ferrules going here. Let's try and keep red and black so that we keep our polarity, or at least red and gray. Okay, so we'll make a couple of these up. Keep red with red. Okay, yeah. I can't go wrong with ferruling your wires. You really can't. Well, mind you, I say that, and if anybody can go wrong with ferruling, it's me. So there you go. You love the word electrocute. It has the word cute in it. Yeah, it does. Black. Oh, perfect. Good. That way I can keep red and black, especially when I'm dealing with actual power. So if I mix it up, then I'm a total idiot. If I mix it up because I'm furling them in red and black. There we go. Okay. Although these ones might not fit the red and black ferrules, but the red will fit. Maybe I'll end up going gray. As long as I keep red constant, red to red. That's got to be stripped a little longer. And so does the black. There we go. Okay. There we go. Excuse me. Good. And the black one, I think the black's going to be a bit big, so I think in this case I'm going to do a gray, which theoretically is a shade of black. There we go. Okay. And then on the battery, on this part, this is coming from the buck converter. This is powering the buck converter. Got to strip some more wire off this. These are tinned wires that are on there. They felt the need to tin them, which is I guess perfectly fine if you're into tinning wires. And there we go. Oh, that sucked. That ripped it right off. Let's just start fresh. There we go. That's better. There we go. Much better. Did you remember the ad in the old Boys Life magazine for the robot you could build out of a trash can? No, I don't remember that. Huh. And we'll go to the red. Oh, that's big. Okay, let's see if I can get that on there. Oh yeah, good. That's going to be strong enough. And we'll go with the gray for the black. Okay. And always test your ferrules. There we go. So that should be good. Okay, let's close this up before I spill it. Okay. Get these little plastic pieces out of the way because they'll end up on the floor if I don't. Okay. So we have our Wagos. Okay, so we're going to go to the battery terminal. So we got one red here. Nice and snug. Okay, this is going to the battery terminal red, and then we have our okay, and our negative. Nice and snug. Okay. Then we have our positive going out, and we have our power going out to the buck converter. Okay. Then we have our negative going out to the buck converter, like so. And then we have our negative going out to the Arduino. Why is that too big? Oh, that one too big? Oh, these little black ones are too big for the Wagos. So I'm just gonna replace these with the gray ones. There we go. Okay, no big deal. There we go. And let's get these little gray ones on here. Okay. There we go. So these should work a lot better. Yeah. Okay, so there we go. There's our combined power. So now we can plug in the buck. And then we can plug in the Arduino. Now on the Arduino, I need to grab my little screwdriver. See what happens if I keep all my tools on the bench? Everything gets overwhelming. Too much stuff on the bench. Okay, a little flat screwdriver. This guy right here. How is the printing progressing? Oh, it's coming good. Here, let's Let's show you how the printing's progressing. See if this works. Let's see. Oh, there we go. Yeah, I can actually go to this and look at that. There we go. It's a little out of focus. Focus, focus. It's coming along. According to the printer, it's got 13 minutes left. So it looks like it's working good. 13 minutes left. Okay, so on the Arduino, we got red and ground. So the ground is the outside one, and then we have the voltage in. So basically here, and voltage in here. Okay. So this one, ground is the black. So that's going to go on the outside here. I got to cut these Wagos. They're a little bit too, or these ferrules are a little too long. So we'll cut that off. See if that works. That's better. So we'll screw the ground in. Give it a tug test. And the red. Whoops. Is that a thing that sounds nasty but isn't? Tug test? Anyways, waiting for Andrew Humphrey to speak up. Oh, when I cut that one, I squished it a bit. There we go. Why are you not going in there? Oh, maybe the red one's a bit too big. I've got to loosen this off a little more. Oh, that ferrule's too big. Okay, well, I do not want to make it black or gray. So what we're going to do in this case, let's see if I can make it white. Yeah, I can do that. Okay, so white is the positive going into the Arduino. There, that's better. I could have made it a gray one too, I suppose, because the actual color of the wire stands out quite significantly. So those aren't going anywhere. Those are in there good. Okay. So we have that plugged in. We have the buck converter plugged in. All that's left to plug in is the battery and see if anything powers up here. Now, I don't know if there's going to be a light that'll come on here when I have power going into it. I'm almost afraid to power it on. Giamatti, hey, Tor, how are you, sir? Giamatti, are you leaving? Did you leave? I must have missed a few things. Timor 714, happy Sunday, just dropped in to say hi. Thank you so much, Timor. Appreciate that. Why does it have to be a test? Why does what have to? Yeah. Let's go ahead and let's plug the battery in and see what happens. So there's a few things that are going to happen. Maybe my buck converter, I will test the output voltage and see if it actually comes out at 5 volts. There's no potentiometer to adjust on this. So we'll see, but let's just plug the battery in and see what happens. Worst case is I give myself a big burn or shock or something, right? So let's just do it. Let's just do it. I say let's just go for it. Oh, hang on a minute. No, 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 no. I just about screwed up. Look what happens. What's wrong with that picture, the way it's going to plug in? Who can tell me what's wrong with that picture? Polarity. I just about made some sparks. So I got the polarity wrong on these. So let me go ahead and change this plug out. Oh my goodness, I'm glad I stopped. Polarity. Where's my little keys? Here's my little keys. Measure with voltmeter. Yes. But let me change the polarity of my wires first. I laughed, but that wouldn't have been too funny. Okay, there's the red one out. Let's fix that little pin. Okay, hang on. Okay, let's take the black one out. Got to keep these separate so I don't short them out. Let's fix the pin again. Okay. Let's get this right. So this is going to go this guy goes in like this. So the black has to be over here, like so. I didn't fix that pin enough. Is it me or is my hand shaking a bit here? I don't blame them for shaking, and the red's got to go over here. Even a 12-volt LiPo battery is nothing to be playing with. Okay, now I think I got this right. Disconnect the pi and connect everything else, then measure with a voltmeter. I just go for it. I'm just going to go for it. There we go. Okay, we have power. We have power to the servo board. We have power to the buck converter. Okay, and we have power to this board. No sparks. Look, we even have a blinking light. It's probably waiting for programming. I'm a gutsy person. I just go for it, right? I have confidence in what I do. So I'm going to measure the voltage coming out of the buck converter, making sure it's 5 volts. No smoke. No smoke. No. YOLO. Okay. The negative is the 5 volt is the outside, the ground is the inside. Turn my meter on. This is a really cool meter. It's one of those, you don't need to set anything. It automatically detects what you were trying to read. Let's see if I can set this, lean this up there so you can see it. There we go. So we're going to go here to here. And so we have 5.09. Oops. There we are. That's coming out of the buck converter. So that's pretty good. 5.16 volts out of the buck converter. Okay, and then if we measure what's going into the Arduino, it should be 12 volts going into the Arduino, or 11 point whatever volts. There we go, 11.43 volts going into the Arduino, and that's the voltage coming out of the battery. Okay, so that's pretty cool. Yeah, and this knows that it's what kind of voltage it is. Like it's kind of a cool little meter. I bought it off one of those Facebook places. So there we go. Okay, so we know everything's working so far. I haven't blown anything up. Yay! Congratulations on the smoke test. Thank you, Papa Way. I kind of feel like accomplished. I was shaking a little bit there, especially when I almost plugged in these 2 wires with reverse polarity. Okay, let me just put a couple things away here. So, okay, so we do have power coming in here. Obviously, one of these is the power. It's bringing ground. So we have ground power, and the rest of them are obviously the wires that program from the Arduino to the servo controller. So far above my head, this stuff, but I am not going to give up. Just going to put a couple things away here. And we're going to do a draw shortly, guys. It's 6:30. We're going to do a draw. We're going to give away some Polymaker filament in a moment here. Yes, we are. Yes, we are. There we go. Wago kit, little screwdriver kit. And these little, or the Wago kit, that was a Ferro kit. This is the Wago kit. Wagos are such a handy thing to have around. Saves a lot of wiring headaches. Okay. Okay, there we go. We're cleaned up a bit. This is still going, no smoke coming. I'm just leaving this on. It's not going to be much of a drain on the battery because there's nothing draining the battery. Let's just see for fun if this other battery has any voltage in it and make sure that I'm polarity is right. Yeah, and this other battery looks like it's got some power to it too. So we have our blinking light in here. We do. And I think the blinking light just means it's waiting to be programmed. Okay, so I'm just going to plug the original battery in. And we're just going to let it sit while we do the draw just to make sure nothing's going to smoke. And I'll put this other battery away in the battery way safe, explosive, fireproof, LiPo guard warning bling bling case. That's where you should always store your batteries, except the ones that are in the robots that are not stored in the case. So where do you enter for the giveaway? Who says you have to enter? I'm just going to randomly pick some. I'm kidding. Give me a second. I will do the giveaway screen here. It is the I'm going to pop it up on the screen in a minute. You all know what to type, but don't type it yet. Not yet. Looks like the print is finished. Yay! Okay, we're going to start collecting comments. So now in chat, go ahead and enter this for your chance to win a roll of Polymaker filament. If you've won in the last 6 weeks, you're not eligible. You guys all know who you are. Congratulations last week to Timor714 who won the filament last week and did claim it, and I did send him his code. Thank you very much to Polymaker for making this. Way to interrupt me, A1 Mini. Thank you very much to Polymaker for making this giveaway possible. Thank you very much, Polymaker partners with 3D Canada. If you do win, if you're lucky enough to win, or whoever is lucky enough to win, because somebody is going to win, I will put my email in chat and you will email me. I just need your email address so I can send you a link and a code to claim your filament. Anybody that tries to pretend to send an email and say, oh, I was the one that won, I will fish you out. There is no fooling me. I promise you, there is no fooling me. Nobody's tried that yet. Everybody's been really good about it. So, and I just gave everybody the idea to try it. Oh, come on. Anyways, no. It can't happen. Can't happen. 34. Look at the entries go up now. That's great. We have 47 people on stream, 34 people entered. This is awesome. Our print finished on the A1 Mini. Is what it told me. We are going to keep the entry open for another 3 minutes. Mr. Logan, hashtag Polymaker, the Ranch Kid, Sissy Kid, Mark Flanagan, Voyager, Brent Ferguson, just Jose Ferreira, Da Vinci 10, Jose Ferreira. Jose Ferreira entered twice. Oh, no, he didn't. He said, hi, Nick. Ha ha. Yeah. You have 47 new emails. Joseph, I wouldn't be surprised. I did open that door, didn't I? But just to show you, look at this. This is, it's finished. El finito. Just come on, camera. Why do you have to do that to me? The print finished. I don't know what's going on this little edge here, but that's obviously something in my model that I quickly didn't do. But anyways, that's okay. Let's cut back to the display. Hashtag Polymaker. And we can cut to this screen. And that way you get an overhead view of me doing this. Oh, that thing's in the way. Hashtag Polymaker. Keep going. Keep going. Now let's do that. There we go. That's better. "37 entries, 48 people watching. 11 people are either ineligible, not listening, or don't want to win some Polymaker filament. And we have no smoke yet. We are still hooked up to our LiPo battery, and we have no smoke. And looks like we successfully wired this sucker up, except for getting all the servos wired in. But I want to see if my little insert plate is going to work. And as Rick Trino said, don't forget to smash that like button. I don't even want to go and look and see how many likes I've got with 49 people watching, but let me go look and see anyways. Even though that YouTube stream feed has frozen, I have 34 likes out of 49 people watching. Well, I'm not giving away this filament until I have 39 likes. Started streaming 96 minutes ago. 2.2K subscribers. 35 likes and I'll do the draw. How's that? Fair enough? All entries are void without a like. Well, you know, if you're a subscriber, your chances are higher. If you hit the like button, your chances are even higher. If you comment and say you love my shirt, hey, you just win. I'm just kidding. I'm just kidding. But there has been a history of people actually just calling the win and they end up winning. So just so you know. But I'm not suggesting anything. So 38, we're going to give it another, we have 637, we're going to give it 639, then we're going to do the draw. Hello, just found me on YouTube, SureShot79. Well, thank you very much and welcome. And hit the like button, subscribe, and even though you just found me on YouTube, you're still eligible. If you type hashtag Polymaker in chat, you're still eligible to win some Polymaker filament. If you just joined, I don't know why I said that 3 times, but if you did just join, you did just find me, you're eligible because you're on my stream. But when I do draw the name, you have to speak up. You have to be here and available in order to win it. There we go. And I would definitely appreciate a subscribe if you did just find me. We tend to have fun on this channel. Unfortunately, I didn't electrocute myself tonight. We put together some electronics for the as far as the Wally build goes. So we got the electronics going here, still hooked up to the battery. No smoke yet. Everything's working fine so far. I don't know if this battery will be powerful enough to drive Wally, but we'll see. If not, I'll put my big 5500 milliamp on it and we'll see. But the nice thing is I can just plug whatever battery I want in it and it should work. So at least that's the story and I'm sticking to it. There we go. Okay, we have another minute. And then I'm going to do the draw. Just got the Bamboo A1 as your first 3D printer ever, and you're loving it. Oh, great. I love the Bamboo series of printers. I do. I'm not an affiliate of Bamboo's. Bamboo doesn't send me any printers, but I love the Bamboos. I have an A1 to 3 A1 minis, 2 P1Ps, and a P1S, and I'm pretty sure they're coming out with a bigger printer in the new year, which I hope they do. Okay, and I'm going to be doing some more, some streams and so forth, talking about Bamboo down the road as we go. So be sure to subscribe and watch out for those videos that are going to come. Videos and mostly live streams. I live stream more than I do videos because I hate editing. Almost had an electro boom moment. Whew. Okay, we are ready to do the draw. We have 40 entries. Everybody's here. I've got a previous list of winners. If you have one within the last 6 weeks, I am going to redraw. There we go. Dan says he loves his Bamboo too, so much better than an Ender 3. Anyone want to buy an Ender 3? Too funny. No, thank you. There's a lot of printers out there for sale all of a sudden, though, on Facebook Marketplace. So let's go ahead and do the draw. We have 40 entries, 53 people watching. Oh my goodness, how many likes do I have? I just want to make sure Hang on one second. I only have 34 likes so far. Let me refresh, see if that went up to 35. Oh, 43 likes. Hey, I'm going to do the draw right now because we have 43 likes. Spin to win. Okay, and 10, 4, 9, 3, 7, 2, 1. Good luck, everybody. Good luck. Who's lucky winner tonight? Dun, da, da, da. The Ranch Kid. The Ranch Kid. Congratulations to the Ranch Kid. Say something in chat. Kid, I'm writing your name down. Got to keep track of everybody. The Ranch Kid. And you have not won yet, so congratulations. Go ahead and say something in chat, Ranch Kid. Do, 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 do. Or did you say something already? And I just didn't see it. The Ranch Kid. There you are. You're here, the Ranch Kid. Congratulations on the win. I'm going to put my email address in the chat right now. It's a real easy email address to remember. I just need your email address so you can send it to me, and it's DeWitt3D. It helps if I can spell my own name. Canada at gmail.com. So there it is in chat, DeWitt3dCanada@gmail.com. Ranch Kid, just go ahead and email me tonight or tomorrow. Email me your email address. Let me know you were the winner of the Polymaker filament. Nobody else dare email me. I will find you. And I have a special set of skills. I will find you. That's a reference to something. I probably butchered it, but hey. And I will email you a link. Tomorrow I will email you a link and a code to claim your Polymaker filament. Congratulations. And thank you once again to Polymaker for making this giveaway available. Their name is going to pop up right here. Thank you so much, Polymaker, for being a partner of the channel. There we go. Old curmudgeon taken. What's taken? What's taken? Hey, old curmudgeon, I haven't seen you in a little while, but hey, how are you? So we still, no smoke on this yet. That's good. Our printed piece finished. So the piece that we did the quick Fusion 360 model on the beginning of the stream did finish printing. Right there. So let's go ahead and see if my little paper measurement thing worked and if this is actually going to fit in Wally. And we have the 2 holes here to look through. No, those are for the motor wires to come through. Let's bring Wally over. Hello, Wally. Hi, Tim. How are you, Tim? I'm good. How are you doing? I am doing fine. Please give me my plate. Sorry, he's losing it. You're now learning 3D printing and you also do sublimation. Oh, on Cry-Cut projects. Cool. I used to do a lot of dye sublimation at my full-time gig, but ended up not making a lot of money on it. So, DeWitt3D Canada, is that a Learn Nissan line? Liam Nissan line? It is. I have a special set of skills and I will use them. I will find you and I will kill you. Missing, I think, is the movie. Okay, let's have a look. Here, where's my other camera view? This is a better view right here. Okay, this goes in on an angle. Sits down in there, nice. Look at that, nicely like that. And now I should be able to. I should be able to theoretically, and I don't want to glue that plate in or anything because I want to be able to get at those screws should I have to ever take Wally apart. And then my wires, if I did this correctly. Oh, how come, where's the red one? Why isn't the red one going through? Hang on. I said if I did this correctly, actually let me separate them first. I'll put one in at a time. It's just a little tight to get up Wally's butt here. Ignore me. And the red one should go straight up through. There we go. Okay. Cool. Oh my goodness. What did I just do? Hang on. I just got them stuck. My own fault. My own fault. I wanted this to be a tight fit, but I wasn't sure. I didn't mean it to be so tight. But hey, it might. Let's just see if I can't. Oh, there we go. There we go. Okay. Now you can get down. Get all those. There we are. Whew. So basically, what's happening now is you can see I've the holes. That's where the motor wires are coming through from the bottom. And underneath here, it's just those screws that are holding the tracks on is what the other ones are blocking. Those are really the only ones that needed to come in. So now I can kind of pack the electronics in without worry about the electronics coming into contact with the those bolts that are under there. I don't know how I'm going to space these electronics out. I don't know how I'm going to do that yet. I may end up making a little thingamadoober so that maybe one of these sits on here, or a couple of these things will sit on here, or I may just make another tray that I slide in that has all the electronics on it so that I can just slide them out and work on them. So, but let's stick the other wires up, Wally, and get these out through that plate as well. And these are all Wally adaptations that I've made that weren't in the original plans. Here we go. And it's hard to get my big mitts in here and to be able to pull this wire through, but there we go. Okay, so we have the motor wires going up the butt, like so. Hope nobody's recording this. There we go. So we have the motor wires nice and tucked away there. I'm really tempted just to stick these motor wires, stick these on a battery and just see it go. I might just do that just for fun, because we don't have a lot of time left in the stream. So just for fun, I want to get the motors running on here and just make sure that everything is operating still. So for the sake of double checking and triple checking everything, I say let's just do it. Rev it up. Yeah, I will. Let's just rev it up and see what happens. They'll go full speed because we don't have any speed controller on it yet. But I've got plenty of wire here to do what I want to do. So let's rev up the motors and just make sure they're still working and that I haven't shorted anything out as far as the motors go. And it's always fun just to see this thing go. So let's connect the negatives together, like so. The inner 10-year-old getting triggered by the up your butt. Well, what else would you call it? It's up Wally's. He's a robot, okay? He doesn't have a real butt, but he does have an underside. Okay, let's grab our bench power. Oh, it's buried under there. Okay, sorry, laser. I got to put you on top. Let's grab our bench power. Make sure we are set to 12 volts, which I think it's preset. I need a power cord. Oh, I just happen to have a power cord here. Actually, it's a brand new one. I gave the other power cord from my bench away when I sold my Prusa Mini. Don't ask what I sold it for. You'll cringe. Okay. Okay. Go ahead and fire this up. Hello, Mr. Bench Power. I think you're set for the voltage anyway. It should be 12 volts. Let's just see. Yeah, 12 volts, right? From what we did last week, 12 volts. Okay. Another handy tool to have if you do a little bit of building and stuff is one of these bench power supplies. Okay, so we're going to do this carefully. Positive. Well, it doesn't matter. It just means the motors will go backwards. Now, I don't want to do it while he's sitting on the bench because it's going to go fast and he'll go crazy. Although, let's just for fun. Whoa. Okay. Scared me. Okay, let's do this. You ready? Don't get my hands on. Let's see what happens. Come on. He works. Is he going forwards or backwards? Whoa! Wally did a face plant. Oh, it's almost like he's going. Are they turning different directions? No, that's not. Maybe they are. Oh, they're turning opposite directions. This has come apart. They're turning opposite directions. So obviously I've got the motors wired a little differently. Here, let's try this once more just to confirm. Oh, did I loosen? Oh, shoot. I think I loosened one of my wires. Yeah, they're turning opposite directions, but they are turning. Okay, let's just see. Let's just go to this side, see which way this one's turning. Hang on a sec. Still at 12 volts. Let's get this guy going. Come on. Come on. Okay, he's going forward. This guy, I think he's going backwards. So Wally's going to go in circles all his life. Oh, what the heck? He's not turning. I know what's happened. Let me turn this off. And this is one of the things I don't like about the design is what's happening here. This guy, I'll guarantee, has come. So basically the motor shaft is glued onto the receptor, whatever you want to call it. And I think what's happened is the glue has come off and it's just spinning freely now. I don't like the way that was designed. So I've got to figure out what's going on there. Not a big deal. Better that it happens now than later. So because it's easy to take these, pop these off and fix them and look at them. But hey, it wouldn't be a live stream without little issues like that. So I'm going to unplug this battery now because these things I know are tried, true, and tested. So what we've got left to do after this week is motors are 180. Well, all I got to do is on the motor, I just got to switch the soldering on the one, or you know what I mean. So because we're not worried about polarity on the motors other than when they are hooked up. I don't like to play in this one. So anyways, we're going to look at that after. But what's left to do after we got the wiring? So basically the simplicity of it is that we can plug all of the servos in. We know where they're going to plug in all into here. We've got the motor. I still got to put the motor into this board, which is going to control the speed. So we're going to run those motor wires to the Arduino board. And then we basically plug all the servos in, plug the motors in, and then sort of tuck everything away and figure out how to tuck everything away in Wally. And then this is where I'm going to need some help from the audience, possibly, because I don't know much about programming these things. But here is where we go, where he talks about his design, list of components, etc. But as we get down here further, he's going to start talking about where we're going to position the servos, if the servos are out or not working, and then the wiring and electronics again, and then down we get to the programming. So he's got code on GitHub, Arduino installation guide. He talks about hooking up a Raspberry Pi to it. Talks about if your motors and if your servos are not operating properly, you have to change some stuff in the code. I don't know what this is all about. I don't have any resistors. So I got to read through all this and see what's going to happen and see what's going on. But this just seems like a lot of work to get this thing programmed. And I'm hoping it's not going to be too boring a job to get all this thing programmed. And then he's got a link to the code on a GitHub site, and we have Wally calibration, we have Wally, we have web interface, and then you go to this, and it's got an INO file, which I think is an Arduino file, yada yada yada, etc., etc., etc. All new to me. So, Jose, have a good night. Take care. Thank you. See you next week. 20 people screaming on advice. I know, Richard? That's going to be interesting. So I'm going to read over the documentation this week a little bit. I'm going to probably steal a Raspberry Pi from my Voron Zero over here, because I don't have a Raspberry Pi and I don't want to have to buy another one. And we'll see what happens. We'll go from there. How come I went from 50-something viewers down to 35 after I did the giveaway? I think some people just come in here for the giveaway and then they say bye-bye. That's all right. That's all right. At least that they've subscribed. They know when we're going to do the streams. They know when we're going to do the giveaway. And one of these days, I'll do a stream that'll interest them, and they will stick around. So, speaking of sticking around, it's time for me to not stick around. We got some pretty good stuff done tonight. What the heck? There were some low moments, some high moments, some fun moments, not so fun moments. But what the heck? We are making progress. Wally's going to go over here for now. We got to get Wally going. I may end up doing, because I want to get moving on to other projects, because this is stream number 7 for Wally. We'll work on it a bit next week. I may do some off-stream stuff with him to try and get him going. I don't even know what I'm going to use to control Wally, unless that's an app on the phone that you use through your Arduino and all that programming Raspberry Pi stuff. So, hey, I'll have him wired up. He's powered up, and we'll see what happens from there. So, everybody, congratulations again to the Ranch Kid for winning the filament. I want to thank very much. I want to thank, where's my mouse? Oh, I want to thank GMND. I think GMND is gone, but I want to thank GMND for the $9.99 super chat. I appreciate that. That helps me keep my channel going. And I will talk to everybody next week as we hopefully maybe 1 or 2 streams left on Wally, and then we can move on to something else. We'll see what happens with that. But until next week, everybody have a great week, and we'll see you all next Sunday, same time, same channel, same place, different shirt, I hope. We'll see. Have a good week, and bye for now, everybody.